Hey y'all, so in this video, this series of videos, we're going to do some problems over here on this sheet. We're going to use a calculator to do all these. They're all ones that become a lot easier or maybe even just possible to do if you have a calculator. So we're going to go over a whole bunch of strategies, some of which are sort of prereqs for a typical calculus class, although people usually need a little bit of a refresher. I'm going to start with number 5 here. Find the maximum value of ln of x plus sine x on this interval. So the first thing that I want to do is I want to check my mode. So I want to make sure I'm in radian mode when we're doing calculus. And then I'm going to go into my y equals screen. You can see here I've got some stuff from having done problem 4. So I'm going to clear that out. And I'm going to type this in right here. I'm going to type ln of x, which is right here. Oops, clear. Let's go up to y1. ln x, and then plus sine x. Close. Now, typically, I like to start with a zoom 6, which I'll do it. And see, mine graphs pretty quick. I'm going to instead use the interval, because here it's asking me from pi over 4 to pi. If I'm trying to estimate pi over 4 to pi on this graph right here, I might not be able to do it right, or I might make a mistake. So I'm going to make pi over 4 and pi the endpoints of my window. So I'm going to go over here to window, and I'm going to say second pi over 4 for my x min, and then I'm going to put pi in as my x max. Now when I hit graph, it's going to go and graph it. Yours might be graphing. I want to give you a tip. If you want to stop it from graphing at any point, just hit the on button and it'll stop it, and then you can go back, right? You probably don't want to stop it because yours is graphing well, but it's a good strategy to have. It's hard for me to demo this because mine graphs a little faster. Anyway, so I want to find the intersection or the maximum. So I'm going to hit second calc. Some of you might think second trace. I tend to say second calc. And see, I've got this maximum option here. So I'm going to scroll down to that 4th option, hit enter. And now it asks me some questions. It asks me to go left of the max. The next one's going to be right bound, and then give a guess. So I'm going to scroll. It looks like there might be a max pretty close to where the cursor is. I'm going to scroll far enough left that I definitely can see that I'm below that or left of that high point. Hit enter. You can see it puts up this little dotted dash thing and it has an arrow going like this. I'm going to go over here, go to the right side of it, clearly to the right side. So we'll go to that pixel spot jump right there. Hit enter. And you can see here it's got an arrow point here. So it's telling me, all right, we're going to look in between these two spots. And then it asks me for a guess. There's 2 ways to do the guess. You can scroll or you can type a number in. I'm just going to scroll here and put it right there and then hit enter. Bam. I get 2.74. So I'm going to pop over here. This is my solutions for the whole thing. I'm going to use this little scan as we're going through here. So I got 2.7074, but look, it says find the maximum value. It doesn't say find the x value, right? So the way that I read that question is that they want the y value for this. So I look here and I say 1.606. So in order to be safe, I'm going to say x equals 2.7, max at x equals 2.74 of y equals 1.606. If I only had the option to give one number for my answer, I would give this right here based on how that's phrased. All right, let's do question 6. All right, so I want to find the value of c for the mean value theorem for this thing right here. So the first thing I'm going to do is I'm going to use the calculator to do as much work as I can. I'm going to type this in for y1. So x raised to the 3rd minus x squared minus x plus 3. Is that right? I think I did that right. I did. So let me pop over to my PDF here. So usually when we're doing mean value theorem, we want to do y of the ending value 2 minus this one. If I want to find the average rate of change. So I could like write all that out and try to, do all these calculations. But if I have a calculator that'll do all the work for me, then I'm going to make it do it for me. So I want to calculate this m right here. So what I'm going to do is go back to my main screen, and then I'm going to hit alpha trace. Actually, sorry, before I do that, I need to open a parenthesis to make sure that I include the entire both these terms in the top of that fraction. So I'm going to do alpha trace. I'm going to take y1, and then my calculator actually take function notation. So I'm going to take it at 2, and then I'm going to subtract, and I'm going to go alpha trace y1, and I'm going to do it at -1, close. And then I'm going to close that parenthesis. Notice this right here is the same as this right here. And then I'm going to divide it by, all right, I'm going to do 2 minus the -1. I can do that in my head. I know it's 3. That's the distance between these two. And I'm going to hit enter. Boom, I get 1. That's where this is right here. So from there, I want to find the values of c that, that make it so that the derivative of this function is 1. So a couple ways to do this when I have the calculator. I look at this, it's easy power rule. I'm just going to take the derivative by hand. So when I take that derivative, I get 3x squared minus 2x minus 1. There's other ways to do it with the calculator. And then I'm going to take and set it equal to 1. So here's my 1. I'm going to go back to my y equals screen. I'm going to just turn this one off by going over and highlighting that equal sign and hitting enter. And I come down here. I'm going to type in the derivative of that thing. The derivative is 3x squared minus 2x minus 1. And then I'm going to hit enter. And then I'm going to type in 1. And what I have is the right side of this equation right here is this. And the left side of the equation is the 1. So I'm going to use my calculator to find the intersect of those two. And that'll be my solution. I should back up a little bit. If you try to solve this thing by hand without a calculator, you're probably going to get stuck. We can't factor it. You could try to use quadratic formula, but it's going to get messy. And if I got a calculator, I want to get a decimal. So one key thing here is, we'll do our standard zoom 6. There they are. But I only want it on the interval from -1 up to 2. So I'm going to take my window. I'm going to make the x min be the low end of that interval, and the x max be the upper end of that interval, like that. Now I'm going to hit graph, and I'm going to clearly see 2 spots right here. So I got to report both of them. So I'm going to go second calc and calculate the intersect. Scroll down or just hit the number 5. All right, so it asked me a handful of questions. Notice mine's starting at y2 right here because I turned my y1 off. If yours has y1 in there because you didn't turn y1 off, you got to hit this down button right here. So first curve. Good, I'm okay with that parabola. Next curve, y equals 1. Want to find that one. So, and then it asked me for a guess. So I'm going to scroll over here to the left till I get close enough to that one. I just got to choose that one over there. And I get -0.548, which I'm going to round up to -0.549 at 3 decimals. Now I got to also find this one. So I'm going to go second calc, intersect again. Going to make sure I get my first curve as the parabola right here. Hit enter. Second curve as this one. Go ahead, and I can scroll around like that. You should see that we can do that, but I want to be at y equals 1 there. So take that. And then for a guess, oh, I'm going to show you something. So I could hold this arrow down and go all the way over. It takes some time sometimes with the calculator. I know my scale is 1, and I can see that this is close to 1. So for my guess, I can actually just type in the number 1, and then boom, it'll go to the spot that's close to that. And it gives me 1.215. And that's where this one right here comes from. Sweet. Hopefully you're good with 5 and 6. I'm going to make another video for number 7.